Hopefully everyone's still awake. Alright, thanks for taking the time to listen to us talk about how we're helping to inspire the next generation of innovators and changemakers that will drive the electronics industry here in Adelaide and around the world. I'm Jack Mansfield, and I have here with me Maddie, Jessica Shannon, and Cara Jenkins, and we're from the Student Robotics Club of South Australia, or the RoboRoos, as we call ourselves. So, we have a challenge. Thinking of the longer term, businesses need a strong workforce to be successful. And if we want to grow our businesses, we also need a bigger workforce tomorrow than we do today. So we need more engineers, but we also need better engineers. Better engineers with both strong technical skills and with well-developed interpersonal and communication skills. People that can work in a team and deliver a result. So how do we achieve that? The answer that we've come up with is that we need to broaden the pipeline of potential future engineers to attract all of the people in our communities, to bring a more diverse background into engineering, including girls, rural kids, and those from low socioeconomic backgrounds. And we need to get all of them interested into doing engineering. Are we missing out by not having these people already? Would we even know if we were? And so how do we do that? How do we broaden our potential pool of engineers? Well, we get kids excited, and we get them excited at a very young age, before they can decide, I can't do that, or I'm not interested in engineering. So the Student Robotics Club of South Australia enters teams into 3 exciting, sexy robotics competitions run by the US organisation FIRST. These competitions give kids a fun, social, team-focused and appealing way to learn the engineering fundamentals, combining the excitement of sport with the rigours of science and technology. We get kids to think about engineering and to look like the girl on the right there, to be excited and to make rock stars out of engineers. What if kids aspired to be top engineers as they currently do top athletes or pop stars? Kids can start out with the first Lego League in primary school and move into the first tech challenge or first robotics competition, which we'll talk in more detail about later, in high school, and continue all the way through to university. Together, these programs can shape the next generation of changemakers that form the future electronics workforce.
Okay, so what are the results that we see from having students participate in programs like FIRST? The numbers that we have from FIRST through surveys of the alumni generally already speak for themselves. We've already seen that over 91% of the students that participate in the program have become significantly more interested in pursuing a STEM career in their tertiary studies. More than this, FIRST also encourages the soft skills that Jack mentioned, with over 99% of students claiming that they can work better in a team as a result of participating in FIRST programs, and over 95% saying that they have had increased leadership skills through the program. But what does participating in a FIRST competition actually entail? So the 3 competitions that the SRCSA runs include FLL, or First Lego League, as our first one. This competition is aimed at students between 9 and 16 years old and requires students to demonstrate their technical skills through a 2.5-minute robot match with a robot made of Lego Technic on an average sized table. It also requires students to identify a problem in relation to a season theme, and it also requires them to solve this problem innovatively, applicably and realistically, and present this to judges in a way that is logical and makes sense. Teams are also judged on their teamwork through a set of judging called core values, which emphasises the importance of being able to work within a team to get anywhere in the STEM world. So through quick observation, FLL already encourages and nurtures the 3 key qualities that we aim to find in our future engineers. This includes technical and intellectual abilities, the ability to identify as well as solve real-world problems, and the ability to effectively communicate and work within a team. FLL is designed to catch students at a very young age, before processes like subject selection within school come into play, which generally requires students to decide where they want to go in life by halfway through year 8, and to give you all some perspective, that's before they're 13 years old. It also is designed to empower students to be able to say, I can, before processes such as streamed classes factor in subjects like maths, which separate the better students from the worst. And I personally know that this discourages many, many students who believe that if I'm not good at maths now, I'm never going to be good at maths. I can never be an engineer, mathematician, or essentially anything within the STEM field. FLL also provides for students who have possibly already built up a bit of a I can't attitude, as well as students who might feel a bit uncomfortable working with the tools and machines that we use to build our bigger robots. And it does this through the use of Lego. Almost every kid has had exposure at some point in their life messing around with Lego. And FLL provides a very, very valuable bridging, which shows kids how the fundamental skills that they learnt playing around with Lego as a kid can be applied to bigger and better things in their lives. So the RoboRoos introduced FLL to South Australia in 2010, and we continue to play a big role in the facilitation and running of the South Australian tournaments, with enough teams now in South Australia to have numerous tournaments in the state and about 1,000 kids per year. Our own teams have also seen significant success in the competition, with the RoboRoos attending the World Championships the past 3 years in a row and having another team travelling to Greece next year. We've won numerous awards, including winning the Global Innovative Solutions Award in 2018, alongside numerous other world-level awards as well as championship awards at a national and state level. FLL builds up basic engineering skills in students, developing their technical abilities, requiring them to identify, think about, and innovatively solve problems, all whilst effectively communicating and working in a team. These skills equip our students so that they are more inspired and better prepared for a potential career in STEM, and provide a stepping stone into our next competition, the First Technology Challenge.
The First Tech Challenge, or FTC, is a more real-world competition and robot as students get to use power tools and build with metal. This robot here is one of our First Tech Challenge robots. This is from last year. Its name is RoboRoos. The software on this robot is far more complicated than you would normally find in FLL, as it's programmed in Java. However, the students still have the capabilities to use block, drag and drop code, so then it's really flexible regarding how complex you want your code to be. In FTC, we start to record our processes, teaching the students the importance of documentation and keeping track of everything that you do, including the failures and bad designs. This program is adult guided but student led, meaning that the mentors are there to nurture and help the students achieve their dreams, but the students ultimately make the decisions. This encourages the students' leadership and management skills. This program is designed to practice, utilize, develop and nurture STEM skills and engineering processes, thus setting up the students for the STEM workforce. In South Australia, there are 12 FTC teams, making up 150 students involved, with 9 of the teams from rural Murrayland or Mount Gambier regions. We support almost all of these FTC teams in South Australia by running workshops throughout the season to support the team in the FTC basics like software and making a drive base. This has allowed our students to not only be leaders within their team, but within the entire state. The third program that we run is the First Robotics Competition, or FRC. This is one of our robots, and as you can see, FRC is a true engineering challenge. With only 6 weeks to design, build, program, and wire a 56-kilogram robot, students have to put into practice their effective teamwork, communication, time management, and technical skills if they want to get one of these onto the field. This challenge has a huge increase in complexity and pressure from FTC. Students work in a full workshop with high-powered tools like lathes, drop saws, and mills. This is also where students begin to specialise into engineering areas they find interesting. For example, electrical, mechanical, software, pneumatics. And we get to work with industry mentors to gain first-hand experience in these fields. The robots are big, complicated, and dangerous. This competition provides hands-on experience, getting students involved and excited about STEM in a sport for the mind competition with all the energy of any major sports competition. First has found that students involved in FRC are 2 to 3 times more likely to go into a STEM degree, becoming your future employees. These competitions aren't just about the robots though. It's also about the social aspects too. Our team has formed a tight-knit community of students that work together to create something amazing. Cooperation between teams is highly encouraged. An atmosphere where students understand that cooperation in a competitive world is the way forward to create a prosperous future.
And now we're back to the big question. What does it take to make the rock stars of the future? Like everything, none of these programs can run in South Australia with just a snap of the hand. To keep these competitions serviceable to so many students within our club and to students across South Australia, it's pretty tricky as a volunteer organisation. You need to keep them at an affordable price, and this takes 3 hard areas to support: material, space, and money. But to continue being valuable to the students we're trying to teach and inspire, we also need people power through outreach opportunities and connection with industries and individuals, like we're doing here today. We need time. We're relying on good people to volunteer time and keep on top of things like accommodation, booking, finances, all those little things. And lastly, we need volunteers and experienced mentors and role models to spend time imparting their skills and passion for their industries to these students. The old story is you can't be what you can't see, and this is even more true with technical fields. We're targeting students who often have never had anyone in their family go into anything STEM related, and sometimes ones who have but find what their parents do completely boring because it just seems like a far off schematic diagram, boring meetings and things like that. This program is hands-on, and we need people with the know-how, people with stuff to provide to us to help bring about the future. It might seem like a lot of time and a lot of effort for industry professionals like yourselves to invest in something like this, but this is the direct investment into the future. And if you could see how excited these competitions make these students, they would look up, you would see that they actually look up to you like rock stars. So, does it really work? Well, the best proof of the success of this program is standing right here on the stage in the individuals that it has produced before you.
So I'm Maddie, and I've been involved with the RoboRoos since year 5. I was about 11. I've competed in both the first LEGO League and the first robotics competition, and as a result of the program, I'm looking into going into aerospace engineering once I've graduated school.
I'm Cara, I'm 15. I've been involved with the club for about 5 years. So since I was about 10. So I've been involved in both FRC and FTC, and I'm currently the captain of the club. So as a result of being involved in this, I want to pursue mechatronic engineering.
I'm Jess. I discovered the club by accident 5 years ago as well, and after just 3 months of involvement and building a robot, I was convinced to go back to my school and change my subject selections. I was on English and low maths and no science, and then I had to go back and say, no, I need to do chemistry, and I need to do physics, and I need to do biology, just let me in. And yeah, so I ended up graduating year 12 last year, being the captain of the club at the time, and taking this lovely robots competition. And now I'm studying pharmacy, working with robots at Pack Medicine at the moment.
And I'm Jack. I have been involved with this for 10 years now. I did the FLL Lego robot and the big FRC robot. I then went and studied electrical and electronic engineering at the University of Adelaide, and I'm now a hardware engineer with Saab. So we've got some question time. No, we don't. All right. We're told we don't have question time.
So everyone, if you could thank RoboRoos again, please. And sorry about the questions, but the RoboRoos are out there in the foyer, and they'll be happy to take any questions and talk to you. My company, actually Don Allen, has been sponsoring RoboRoos for a number of years. I seriously suggest that you consider it and getting engaged